Good evening, Pooja. Wait for a few minutes for others. Yeah, good evening, everyone. We'll start. It's already 5:30. Shall we start?
Good evening, sir.
Yeah. See, anybody can give the quick revision what we discussed yesterday? We are discussing two statements as the theorems, theorem number 3 and 4. If A is any natural number, A is any natural number, and P is a prime number, such that P divides A square. P divides A square, or A power n also I can say. A power n also I can say. Then P divides A. Then P divides A. Because of P is prime. P is not prime, we can't say P can divide with A. Suppose if I am taking 64, where 2 is a prime, 8 square is divisible by 2, where 2 is a prime number. According to this statement, I can say 8 also divisible by 2. That's what he's trying to say. Is it clear what I'm saying? Guys, what is this theorem says? Shall I go for the next? Another one is, if A and B are any natural numbers, if A and B are any natural numbers, and P is a prime number, and P is a prime number. How this prime number? This prime number is in such a way such that P divides AB. P divides AB. Then P divides A or divides B or both A and B. With an example we discussed yesterday. Both A and B. Suppose if I am taking a multiplication 8 into 9 is equals 72, where 72 is divisible by a prime number. If I am considering, so A and B are any natural numbers, where 72 is divisible by a prime number 2 or a prime number 3 or any other prime number can divisible with 72. Guys, other than 3 and 2? Other than 3 and 2, is there any prime can 72 can divide? Guys, there? Yes, sir. No.
No, sir.
Yes. No other primes. So what is this statement says? So if 72 is divisible by 2, and I'm taking 8 into 9 is as 72. So 8 can be divisible by 2, or 9 can be divisible by 2, or 8 or 9 can be divisible by 2. Any one statement compulsory, it will divisible. So in this case, first statement and sorry, not both, 8 and 9 both. So only 8 can be divisible by 2, and 7, if I'm taking 3, 9 can be divisible by 2. So either A or either B or both can be divisible by that prime. That is the second statement. This why I'm stressing these two statements. These two statements are little important for us to discuss whether to prove whether it is a rational number or irrational number. Now I'm going back to yesterday theorem. The next one is this I am considering as a theorem. Prove that root 2 is a rational number. We will make it as this statement is a theorem. Prove that root 2 is an rational number. We are considering this statement root 2 is an irrational number. This statement we will consider as the standard statements for upcoming numericals. See, what is the logic in this statement? How we prove? We are not going to prove this is a irrational number. We are not going to prove this is an irrational number. What we are trying to do here, because we don't have any particular method or particular rules to say whether this is irrational or not, but we are having a particular definition to say a number is rational or not. Am I right, guys? What I'm trying to say? If a number is not rational, definitely it is irrational, because we are having only two classification. The whole numbers can be able to classify into two categories, either rational or irrational. Everything falls under either rational or irrational. But in future, we are going to learn a new number system called complex numbers that is not yet discussed. Yeah. So what is the strategy is here? We are considering opposite to that statement what is irrational. That means we are assuming yes, it is rational, and we are proving that is wrong. What is the meaning of wrong means it's a contradictory statement. What other thing I am assuming it's a contradictory. So how I am saying is let root 2 is root 2 be a rational number. What is the definition of rational number, guys?
It
should
be a form of P by Q, where
P by Q form,
0 and P and Q are integers.
where
Which does not
P
have a
comma Q are
integers,
integers,
and they don't have
and Q should not equal to 0, and P comma Q have no common factors. Suppose out of these three statements, if any one statement failed, suppose I can do any kind of arithmetic calculation for this expression. This is an equation for me. This is a mathematical statement. I can do, and it is an equation. I can do any kind of arithmetic operations. I can add something on both sides. I can multiply on both sides. I can divide on both sides. I can do anything related to mathematics. But because of any addition, subtraction, multiplication, or division, these statements should not comes under as a false statement. If it is happening like that, then it is a contradictory statement what I assumed. So I am doing certain mathematical operations on this. So what I am trying to do is I'm checking what are the factors of P and Q, because P and Q are integers. Using this statement I can't do anything, but there is only one statement according to the definition of this. P by Q is a form of a rational number. It doesn't have any common factor, but if I am able to prove P and Q have some common factor, then I can say root 2 is not a rational number.
What is contradictory, sir?
Sorry?
Sir, you said contradictory statement. What is it, sir?
Contradictory statement means what I assumed here.
Let root 2 be a rational number.
No. This is not assumption. This is a definition of rational number. But my assumption is what?
So root 2 is rational.
My assumption is root 2 be a rational number. Correct?
Yes, sir.
Contradictory statement means after some time I am saying this is not a rational number. So one person available at a time, two places, like that. And one place I'm saying this is right, and another step I'm saying this is wrong. That means what? Either one should be wrong now, correct or not? Either one step should be wrong out of both. Like this is a contradictory. What other thing I am assuming, what other statement I am getting in future, it's not matching. It's not matching means there is no relation. In the first step, I am saying it is rational, and then the some other step it is showing it's not, it's violating that statement. What other statement you are getting in the process of mathematical calculations, it's violating your assumption. So that statement is called contradictory statement. Got it? What I'm saying?
Yes, sir.
It's very simple. I'm taking a plus b is equal 25, and I'm doing some mathematical operations. After that, I got a plus b is equal 45. Is it possible? Where a, b are natural numbers, I'm saying. I done some mathematical calculation here. So in the process of calculation, I got again a plus b is equal 45. Here a plus b is equal 25. Here a plus b is equal 45. And what is this meaning? This statement is contradicting my assumption here. Got it? What I'm saying? How it is possible sum of two
Yes, sir.
natural numbers having two different values? Is it possible? No, no.
No, sir.
So that is what I am trying to say here. See here, what I am doing is I consider this is a rational number. According to the definition of the rational number, it should be in p by q form, and the definitions of p is p and q should be integers, q should not be equal to 0, and p, q have no common factors. Suppose in future, if I am getting p comma q having a, if I am able to prove p comma q has a common factor, that is a contradictory statements. I consider it doesn't have any common factor, but I am getting common factors. So that means my assumption is wrong. If my assumption is wrong, what is the other option I am having? If it is not rational, no other option I am having. It should be
Yes,
irrational.
sir.
That is what I am trying to say.
Okay,
Clear?
sir. Yes, sir.
So I am taking square on both sides. Root 2 is equal to p by q according to my assumption, square on both sides. What will happen if I am square on both sides? 2 will be equal to p square divided by q square. This can be written as p square is equal to 2q square. What is this meaning? What is this meaning? P square is having 2 comma q square are factors, correct? Correct or not? If I am writing a number 2 is equal to 1 into 2, 1 comma 2 are factors. If I am writing 4 is equal to 2 into 2 into 1, 1 comma 2 are factors here. If I am writing 6, 2 into 3, 2 comma 3 are factors. So I can say 2 is a factor for p square and q square is also a factor for p square. According to the statement, see here, what is the statement says? P is a prime and p divides a square, p divides a also. So here I can say 2 divides p square. I can say as 2 divides 2q square. So 2 divides p square. According to what other discussion we had in a theorem number 3, if 2 divides, 2 is a prime number. If a prime number is dividing a square of p, some p square, so 2 divides, and 2 is a prime. If a prime number dividing a number p square, so that prime number will divides p also. 2 divides p. So what is the conclusion statement is 2 is a factor of p. Correct? I can say till here it is clear, guys, how to write the steps. Any confusion still here?
So it's clear.
Now, I am continuing my statement. So what I am doing is, so P is 2 is a factor of P. So I can say let P can be written as 2 times of some other number where M is an integer. Where M is an integer. Here I proved 2 is a factor of P. If 2 is a factor of P, according to division lemma, I can write P is equal to 2M plus 0. Correct? Square on both sides again. This will become P square is equal to 4M square. From previous discussion, we already know P square is equal to 2Q square. So what I am doing is, I am substituting this P square value here. Substitute P square is equal to 4M square in above equation. So 4M square is equal to 2Q square. 2 times this is coming as Q square is equal to 2M square. Q square is equal to 2M square. That means as 2 divides 2M square, so 2 divides Q square also, and 2 is a prime. If a prime number dividing a square, that number will divide the square root also. I can say from here, from that theorem number 3, 2 divides Q also. From here I can say 2 is a factor of Q. From above all the discussion, what I can say, 2 is a, this is important step, 2 is a common factor for P and Q, which is a contradictory statements. This statement is, this contradicts, which opposes, which proves wrong, that P and Q have no common factors. See, in the beginning I proved, I assumed P and Q doesn't have any factors, but I am able to prove it is having common factors. So that means I am assuming it doesn't have any common factors, but I am able to prove, which is contradicting. Contradicting means it's like it's not true. Whatever the assumption you are taking, whatever the statement you are considering to say yes or no, it's wrong statement. So what I can say, hence conclusion statement final. Hence root 2 is not rational number, that is root 2 is an irrational number. Simple. Got it, guys? How to approach this question? Any doubts? See, the statements, the procedure, it's your wish. Only we are using theorem number 3 and definition of the rational number and irrational numbers to say root 2 is an irrational. We are assuming this is rational and we are proving somewhere it's not irrational. So which is opposite to my assumption. So which is contradictory statements are coming. That's the reason I can able to prove this is an irrational number. Anyone having any doubts anywhere like, sir, what is this step? How to write? Simply I can say I assumed P comma Q doesn't have any common factor, but the statement what I am getting in the process of calculation, which is opposing my assumption. That statements are called contradictory statements. One statement is opposing another statement, but both the statements are done by you, one person or one idea or one methodology only. Is it clear, guys? Shall I
Yes,
move?
sir.
So with the same kind of approach, how we can prove a root 3 is an irrational number? Same method. I'm not going to use any kind of different method here. The statement is, see, root 2 as is an irrational number. This we will consider as a theorem. Irrational number. This we will consider as theorem. So now, next, it's like a question. Prove that root 3 is an irrational number, same as root 2. What is the first step? Guys, what is the first step? Anyone? Please take initiation, please. Anyone can give? What is the first step? What I have to do from the previous thing?
We have to assume that root 3 is a rational number.
Let assume root 3 is rational number. According to the definition of the rational number, root 3 can be written as P by Q form, where P comma Q are integers, Q not equal to 0, P comma Q doesn't have any common factors. So if I am able to prove any one statement is opposite statement, if I am able to create any opposite statement on this, then it is contradicting my assumption. So now what is the next step? Take the statement root 3 is equal to P by Q, whatever the thing I am assumed, square on both sides. I will get 3 is equal to P square by Q square. This will be P square is equal to 3Q square, where 3 is a prime and 3 divides P square. So 3 can divide P also. That is 3 is a, according to theorem number 3, 3 is a factor of P. 3 is a factor of 3. If any number is a factor of some other number, I can write multiples of that number. So from here, I can write P is equal to 3M, where M is an integer. So square on both sides. P square is equal to 9m square. From the previous discussion, P square is equal to 3q square, and I'm substituting, I'm equating these two equations. 9m square is equal to 3q square. From here I can write q square is equal to 9m square by 3, that is 3m square. So q square is equal to 3m square, where 3 is a factor of q square, that is q square, and 3 is a prime. 3 is prime number. So q square is divisible by 3. According to theorem number 3, q also divisible by 3. That is 3 is a factor of q. So from the above discussion, from the above discussion, 3 is a common factor for both P and Q, which contradicts P and Q doesn't have common factors. Hence, what is the conclusion statement, guys? From here, anyone can give the conclusion statement? P is not a rational number, that is, sorry, root 3. Root 3 is an irrational number. Clear? Clear, guys? Any doubt? How to write the steps? Got it? See, mostly we are using theorem number 3. Theorem number 3 means the first statement what I wrote here. If A is any natural number and P is a prime number, such that P divides, if P is a factor of A square, then P is a factor of A also. That's the statement we are using. Now, can you do by your own? I am not giving any number. This is my statement. Try to do this, guys. Prove that root of p is an irrational number, where p is a prime number, where p is a prime number. P is a prime number means other than 1 and itself, p doesn't have any factors. If we are able to prove p is having some factors by assuming it is rational number, then our job is done. Try, guys, please try. I want to see whether you people can able to try or not. Please use any strategy. Try. I will give 2-3 minutes time. If you are able to do these questions, we can able to solve all exercise questions very easily. Doesn't matter. Guys, anyone done? What is the first step I have to take? Anyone?
Sir, we have to assume
Let's assume root of p as a rational number.
Root p is a rational number. So if it is rational number means it is already p is there, so I can't take it as p by q as the some other notation. So root p I am assuming as m by n, where m comma n are integers. N should not equal to 0. M comma n doesn't have any common factors. And before that, you can include one statement: according to given data, P is a prime number. I think everybody knows what is the definition of the prime number. It doesn't have any factors other than 1 and itself. Other than 1 and itself. Now, I'm taking the statement root p is equal to m by n, square on both sides. So I'm squaring on both sides. P is equal to m square by n square. m square by n square. I am getting m square is equal, sorry, p square is equal to m square by n square. P square n square. P square, sorry guys, very sorry. P is equal to m square by n square. So m square is equal to p n square. P n square. So p into n square. So m square is equal product of p into n square. How I can say p is a factor of m square, that is p divides m square according to the theorem. According to the theorem, what are the theorem we discussed in the beginning? P divides m also. Why? Because p is prime. If a prime number divides a square number, it will divide its square root also. That is what we discussed in that theorem. Now p can be written as, that means p is a factor of m also. That is p is a factor of m. So if any number is a factor of m, I am writing m is equal to p into some other integer where k is an integer. That is the meaning of factorization. So it can able to multiply with any other number. So m is equal to pk square on both sides. M square is equal to p square k square. From previous discussion, we know m square is equal to p n square. M square is equal to p n square. And here we got m square is equal to p square k square. Equating these two statements, p n square is equal to p square k square. P n square is equal to p square k square. From here I can write as n square is equal to pk square. Again, p is a factor of n square. From above, from previous step, p is a factor of n square, because n square is a product of two different numbers and p is a prime. So according to theorem number 3, what I can say, if any prime number is a factor of a square, if any prime number is a factor of a square, p is a prime and factor of n square. So p can be divides n also. What it is trying to say, from above discussion, p is a common factor for both m and n, which contradicts m and doesn't have common factors. So root p is not rational number where P is a prime number, that is, for any prime number, the root of prime number is always an irrational number. I can say like this, guys. Is it clear? So now no need to worry. This is also we can consider as one theorem. But root 2 is an irrational number. Root 2 is an irrational number. That is only we'll consider as theorem. But like this, we can able to prove using. See here indirectly we are using fundamental theorem of arithmetic and as well as division lemma. These two only we are using. See, that is based on that only theorems was designed. Those theorems only we are using to prove root of a prime number is an irrational number. Is it clear, guys? How to do? Any doubts? Clear? Anywhere, any statement, the way how to write and all, anyone having any difficulty?
Sir, it's clear.
So shall I go for any numbers instead of going variables now?
Yes, sir.
Other than root 2, root 3, now we can able to prove root 5 also. Suppose if I am giving root of a composite number, how to prove whether it is rational or irrational, that we will see if time permits today. Okay. Before that, we will go for one more number. Show that. I will give some time. I am expecting answers from you. Show that 1 by root 2 is an irrational number. Try this question. 1 by root 2 is an irrational number. Same method. Whatever the thing you done for last three, I can say it's like an applications of your division lemma and algorithm prime factorization concepts. Those we are considering as theorems. Root 2 is an irrational, root 3 as an irrational, root prime number is an irrational. Same method. There is no like the strategy is same. There is no difference. If anybody completed, my next question was prove that root to 10 is an irrational number. Root to 10 is an irrational number. First, I need the answer for first one. If anybody completed, please let me know. In exam, you have to write this statement to explain this one. First, you write this statement. We know according to a theorem, if A is a natural number and P is a prime number such that P divides A square, then P also divides A. That right? And you can explain from that theorem, you can say this one. Anyone completed, guys? Yes, anyone done? 1 by root 2 is irrational. Is an irrational number. Anyone done? Guys, some response. Yes or no? Pujita?
You're doing, sir.
Huh? Anyone not clear? Stuck anywhere? Let's say I'm doing. Who is not yet done? Please just follow, or rest of the people can carry on with your solution. Like whatever thing you are doing, please continue. Let's see. Same. Let assume 1 by root 2 is a rational number. So 1 by root 2 is equals P by Q, where P comma Q are integers. Q should not equal to 0, and P comma Q doesn't have any common factors. These are the three statements we are going to prepare for according to the definition of the rational number. These three statements I am writing according to the definition of rational number only. Now, what I can do? So take the statement 1 by root 2 is equals P by Q square on both sides. So this will be 1 by 2 is equal to P square by Q square. After cross multiplication, I will get this will be Q square is equal to 2P square. Consider this is an equation 1. From this equation, I can say as 2 divides 2P square, 2 divides Q square also, and 2 is a prime, and 2 is a prime. 2 divides Q also. From theorem number 3. From here, what we can write again? If 2 divides Q, 2 is a factor of Q. So Q can be written as 2m, where m is some integer. So square on both sides. Q square is equal to 4m square. This is equation 2. From equation 1 and 2, Q square is equal to 2P square. Q square is equal to 4m square. If I am equating both the equation, I will get P square is equal to 2m square. So from here again, you have to remember that theorem. What is that theorem? 2 divides as 2 divides, or you can write in a different way. 2 is a factor of 2m square. So 2 is a factor of P square, and 2 is a prime number. So if 2 divides P square, 2 divides P also. 2 divides 2m square. So 2 divides P square, and 2 is a prime. 2 divides P also. So again, if 2 divides P also means 2 is a factor of both P and Q from the above discussion. Which contradicts P comma Q doesn't have any common factors. So 1 by root 2 is not rational number. So 1 by root 2 is an irrational number. Is it clear, guys? Same kind. Again, methodology is same. Only the thing is, instead of P square is equal to Q square, in this case we got Q square is equal to 2P square. Clear?
Yes, sir.
So same way, can you do for root 10? You can try later. I'm going for some other thing. You do second question, you try by your own. This root to 10, you can try your own. Same as root to 10 is equal to p by q, 10 is equal to p by q square. So p square is equal to 10q square, 2 into 5 into q square. You can start 2 is also prime, 5 is also prime. Any number you can consider, you are having the two options here. So you can write if 2 or 5 can be divisible by 10q square, it can divides 10q square. So p square also can divided with 2 or 5. So both 2 and 5 are primes here. Like that you can explain. But I'm going a little bit related application questions. Look at this question. That question you try. If you are unable to get, try by your own. If you are unable to get, we will discuss in next class. Show that the number 7 minus 2 root 3 is an irrational. Is an irrational. Irrational number. Here we are not going to prove like earlier because we already proved root 2, root 3 and root of any prime number is a irrational number, is an irrational number. Using those statements we are going to discuss. We are not going to take p by q and we are not going to square on both sides and all we are not doing here. I am assuming this number is equal to r. I am assuming this number is a rational number. The first statement is common. Assume 7 minus 2 root 3 is equal to r, where r is a rational number. I'm not going to define also. It can be written in the p by q form and all. What I am going to prove is, I am going to prove r is irrational. So which contradicts my assumption. So 7 minus 2 root 3 is equal to r. From here I can write minus 2 root 3 is equal to r minus 7. Multiply minus 1 on both sides. So 2 root 3 is equal to 7 minus r. Root 3 is equal to 7 minus r by 2. Is a rational. Why it is a rational? 7 minus r is an integer, because 7 minus a number and subtraction with an integer is it, and 2 is also an integer. Seven minus r, so total I can no need to write separately, guys. You can write 7 minus r is also 7 minus r is also a rational number. So no need to write both. So which is saying if r is rational, 7 minus r also rational, and 7 minus r by 2 also rational. This statement is clear. And which says root 3 is rational number, but root 3 is an irrational number, which we proved earlier. So which contradicts root rational. So you write a clear statement, hence our assumption is wrong. Therefore, or you can use the symbol for therefore, 7 minus 2 root 3 is an irrational number. Guys, understood what is the fact behind this? We are not going to say P by Q and all here. Yes, we are going to take and we are proving it is equal to some irrational number. So a rational number can't be equal to irrational number. Like that we will prove it's an irrational number. Is it clear? Anyone having any doubts? Please respond.
Sir, it's clear.
It is
Yeah.
clear, sir.
Next, I'm going to copy some questions. Please try for the next class. Already I gave one question here. Try to solve these questions for your next class. Show that 7 root 5 is an irrational number.
Sir, I have a doubt, sir.
Yes.
Sir, in the last sum, sir, you said that root 3 is not a rational number because we have proved already.
Which one here?
Yes, sir, the last step. Like root 3 is not rational because we have already proved that it's
Yes,
irrational.
correct. Yes, yes.
So, we know that we have proved that root 3 is irrational, sir, but in the exam point of view, we have not done any sum, like before we had not got any sums like
We
that.
are considering the statement of root P is a irrational number. Root of any prime number is an irrational number as the theorem.
Okay, sir, so that
Right
statement,
here in the bracket you write from theorem root of prime number. Root P is irrational if P is prime. I can use the statement here
yes, sir.
in exam. Or we can in exam also you can write we already know root 3 is an irrational number which we are considering as a theorem.
Okay, sir.
Like that also you can write, but better you write. We know the theorem root P is an irrational number if P is a prime. Clear?
Okay, sir.
That is enough. No need to explain all the things. 7 root 5 is an irrational number. The next one is prove that root 3 plus root 5 is an irrational number. Next one is prove that one by 2 plus root 3 is an irrational number. Next, prove that root P plus root Q are is irrational if P and Q are primes, prime numbers. Last one, prove that the sum of a rational number and an irrational number is always an irrational number. Hope you understand what you have to try. Total 6. These are the 5 sums and one more sum I gave. Clear, guys? Shall I wind up the class? Anyone having any doubts?
No doubt, sir.
Yeah, we'll meet in next class. Bye, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.